If you're a construction project engineer or junior construction manager and struggling to understand how to coordinate and manage site works, or maybe you've heard the term of a short-range program or 3-week look-ahead and want to actually understand how to build and use one, then this video is for you. In this video, we're going to talk about how to implement a project schedule. We're going to talk about how to take a plan and put it into action using short-range planning. A lot of time we hear people talking about how to develop a schedule, but once we've built a plan, the next step in project scheduling is to put this plan into action. And implementing the schedule is a fundamental part of project scheduling. This talk is part of a series of talks we're doing on how to equip project engineers and junior construction managers with the fundamental skill of construction project scheduling. There are 4 separate talks we're doing. The first one is on understanding project scheduling. The second one is on how to develop a project schedule. The third one, so this one, is on how to implement the schedule. And the fourth one will be on how to track and monitor progress. When we talk about implementing a schedule, we're going to be talking all about short-range planning and how to take a plan and put it into action. Before we get started, a little bit about us. So my name's Tim. I'm a senior project engineer with 10 years of experience in the industry. I've also got my PMP, so project management professional, and I'm a chartered professional engineer in electrical engineering and project management. My colleague Ashley, who I've been making these talks with, is a senior commercial risk manager with almost 15 years experience in the industry, and he's also a chartered engineer. If there's one thing we've learned in our time in the industry, it's that so many people don't have a good grasp of the fundamentals. And the people who really excel and accelerate their careers are the ones that understand the fundamental construction project management skills and apply them in their job. And so that's why we've created a learning academy, Construct IQ, to teach the basics and show you how to grow your career. So far, we've helped over 20,000 students, and over 94% of students we've surveyed have said that mastering the fundamentals has helped accelerate and grow their career with our courses. This talk is going to be broken down into 4 separate sections to cover the basics of implementing a construction project schedule. We're going to talk about the key concepts, how to read the master project schedule, how to develop a short-range program, and then we're also going to talk about lead times and pool planning, probably the 2 most important concepts that are going to drive a short-range program and impact your ability to implement the schedule. Let's get started by looking at the key concepts of schedule implementation. So why is schedule implementation an important topic? Well, a plan has no value if we don't follow it. The only value scheduling has if we actually use it to change the way things are done on site. And so schedule implementation is the second step in project scheduling. So first we need to build a schedule, and then we need a way to put this plan into action. So schedule implementation is then the process we use to plan, coordinate, and deliver the construction works in accordance with the schedule. So many people think of project scheduling as purely the art of putting together a schedule. They associate project scheduling with sitting in front of Microsoft Project or Primavera for hours and putting together a massive Gantt chart. I was working on a major rail project, and a colleague of mine spent weeks preparing this super detailed schedule for the station build. By the time he'd finished, it wasn't even relevant. It was developed with the wrong information. It had no bearing on the actual way the project was going to be built. The entire time he spent building this schedule contributed 0 to the project. When we talk about project scheduling, yes, we need to talk about development. Yes, we need to talk about how to create a network schedule, how to estimate activity durations. But we also need a set of tools and processes we can use to take this plan and put it into action. We want a way to actually deliver a project in accordance with the schedule. I'm going to go so far as to say that planning without action is a form of procrastination. It adds no value to delivering a project. So to get started with schedule implementation, the first thing we're going to talk about is how to read the master project schedule. This is the first step of schedule implementation. Before we can put a plan into action, we actually need to understand what the plan is. As I spoke about in our last talk, the master project schedule is the overall plan that covers the entire project scope. It covers everything from early stage design to pre-construction activities to project setup to procurement of long lead time items to then the construction to then the handover and the commissioning. It's the entire project scope. And activities in it are generally pretty high level, but it shows the logic of how the project's going to be built and the key linkages and overall timeframes and durations. Our job is we need to read, analyze, and interpret this schedule and how it impacts the scope that we're going to be coordinating and managing. Up on the screen, I've got an example of a detailed schedule that's been created in Microsoft P6. The planners and project controls team will be using something like Primavera or P6, which is really good for handling massive amounts of tasks and activities. In the furthest most left-hand column, we've got the separate activity IDs and then the activity names. So every single task in the project is listed out. And then these are grouped under subheadings. These subheadings would reflect the types of levels we've got in our work breakdown structure. Then you can see a column that has critical, so whether it's a critical path activity or not, the type of calendar that's used. So if you refer back to the last talk we did, we spoke about how that you could run a project with day and night shifts. You could run a project working Monday to Friday. You can work public holidays. Some activities you can do when it's raining, some you can't. So there's different calendars for different activities. Then we've got the float, and the amount of time an activity can be delayed before it impacts the critical path. So an activity with 0 float is an activity that, if it's delayed, will push out the project completion date. Then we've got the original duration, and then the start and finish date. And then across the screen, you can see that these activities are visually represented with a Gantt chart. So for each activity, you can see against the calendar on the top what day it's planned to start and what dates it's planned to finish. You can then see the activities in green represent one work breakdown structure and the activities in red represent another. There's lots of different ways you can plan and present things in Microsoft P6, but the key things you want to look at when you're looking at a schedule is be able to understand what the activities are, what their planned durations are, and when they're planned to start. When you're reading a plan, something I want you to keep in mind is that schedules are always wrong. And I'm not saying this because I want to make a point that planners are bad or that people who are in project controls team don't do things properly. Not at all. You can never perfectly build something in your mind. And at the end of the day, when you're preparing a schedule, that's what you're doing. You're trying to build a project in your mind. The way that transposes to the things that are actually going to be done is certainly going to be different. There's going to be activities and linkages that are missed. There's going to be specific constraints and circumstances that you haven't thought of that come up. And there's going to be detail missing. On top of that, construction projects occur in the real world. They're not in controlled environments like a manufacturing plant. And change will come up. So when you read the schedule, you want to read it critically. This means you're questioning things when you see them. When you think, okay, if this activity has to occur before that one, why is that the case? Is that correct? They're the questions you want to be asking yourself when you're reading the schedule. So you want to question absolutely everything. And then when you're doing this, it's going to help you understand logic. If the schedule says trenching starts on the 1st of March, that's not necessarily going to be a fact. You have to understand, why is it the 1st of March? What activity is driving this? Is it procurement of a subcontractor? Has procurement of a subcontractor been considered? Has the fact that you need to get a permit to trench across utility communications cable and that you have to apply for this permit 6 weeks before been considered? So can this activity actually start on the 6th of March? And so what I'm trying to say is your job isn't to blindly follow the schedule. Your job is to achieve the project outcomes. And this means finishing the project on time and hitting all the milestones you need to. And so it's better to look at the schedule critically and then work with the project controls and planning team and feed them back information that it is just to blindly follow everything it says. So once we've understood the schedule, we've got our head around the project scope. And remember, I'm saying this in the context of a junior construction manager or project engineer. So you're going to be managing a small package of works. But even though you're just managing a small package of works, you still want to understand the project as a whole. So the next thing we're going to do is, for the package of works that we're managing, we're going to create a short range program. What is a short range program? Well, a short range program is a highly detailed schedule that covers a short period of time in the future. And it's basically a tool we use to plan and coordinate everything that has to happen to achieve the targets in the master project schedule. So while the master project schedule will be done in Primavera P6, a short-range program can be something as simple as an Excel table or even just something on a whiteboard in an office. And the first thing we want to do when creating a short-range program is defining the time window we're going to be looking at. So this is time slice, so the window of focus. So you could have a 3-week look ahead, you could have a 6-week look ahead, or you could have a 9-week look ahead. And on the scope of the schedule is going to be everything that needs to happen to meet the objectives in the master project schedule in this period of time. So what's everything that has to happen in the next 6 weeks, and what are all the subtasks we need to do to achieve it? We're going to decompose the schedule and add detail to it. So the master project schedule might say basement excavation starts, but then our short range program, our 3-week look ahead, is going to have everything like floating the machinery to site, the surveyor coming to site and marking out the extents of the foundations, setting up temporary barricading around the excavation, excavating to the design depth, and then setting up temporary works and shoring. So you see, this short range program takes a single activity in the master project schedule and turns it into a fully detailed list to make this happen. Through this process, we're adding significant amounts of detail. We're decomposing every task into a set of subtasks. We're understanding the methodology with which we're going to complete the task. And then it's also helping us understand for each of these subtasks, what are their own durations? What are their own linkages? What are their own considerations that we need to make to ensure that they happen? Let's look at a really, really simple example of a 3-week look ahead. This is just a table from Microsoft Excel, which is all it has to be. It doesn't have to be something complicated. And I would go so far as to say the more complicated you make it, the harder it's going to be to continually update and change, because 3-week look aheads change every single day. So on the left-hand column, we've listed out all the works on site. We've got the subcontractor responsible for it. We've got the permits we need to have in place. So for example, for any trenching, we'll need an excavation permit. And then we've written down the permit number so we know that this permit is available. And then we've got any additional resources we need to book. So for example, the trenching and pit installation, we need a service proving truck. And then we know the dates that this task is going to have, and this is going to help us book the resource. And we've got the duration and the planned start and finish dates. So yeah, this is a really simple example, listing out tasks and the resources they need and the durations. But you can chop and change this depending on the project you're working on. So for example, you've got an open RFI or questions from the design team. Maybe you want to list out these as well. If you've got procurement tasks, if you've got materials that you need on site, this is all the sort of stuff you can put into your 3-week look ahead. And you really want to tailor it to the project you're working on and the specific issues, the specific things you're facing. Because at the end of the day, it's a tool to keep the job moving. And you want to have on there everything that's going to impact the works. And when we looked at that 3-week look ahead, we spoke about things like permits we need, materials, and all these things take time to organize. And that's why when we talk about a short range program, we need to understand the concepts of activity lead times and pool planning. So if you listen to the last talk I did, where I was talking about the importance of scheduling, I spoke about reverse engineering project success. So looking at the outcomes you want to achieve and then thinking about everything that needs to be in place to do it. Schedule implementation is exactly the same. We want to reverse engineer the task. We want to think about everything that has to be in place to complete the task. So this concept is called pool planning. So the idea is that rather than starting with a schedule from the start to the finish, you start with a finish and work back to the start. And you're thinking about for each activity, what has to be in place to complete the task. And we're going to do this by visualizing the task, understanding the task, and engaging with people who've done the tasks. If we do a quick example of this for a concrete pour, you'll sort of understand better what I'm trying to say. So for a concrete pour, we want to try and think of everything that has to be in place to complete the pour. So there's pre-works. So if it's a foundation, there'll need to be excavation work completed before. A surveyor will need to come and mark out the extents of it. And if there's utilities or services going through or under the slab, these are going to be needed done before. Then we're going to need the materials that we need to complete the pour. So we'll need all our formwork, so form ply and bracing that's going to create the shell of the pour. We're going to need steel reinforcement, and we're going to need maybe consumables, tie bars, screws, all the actual materials we need to to put in place for the pour. We're then going to need to organize someone to do the pour. So we could have a subcontractor coming to site to do it. We might be using our own labor. Then we might need plant and machinery as well. We might need a concrete pump. We might need a kibble, depending on the methodology. We also need all our safety documentation in place. So we'll need a SWMS or a safe work method statement for the task that's been prepared and reviewed. And then we'll need quality documentation. We'll need to have prepared an inspection and test plan to cover the activity, and we'll need our clients reviewed it. None of this is going to be in the master project schedule. All these specific subtasks aren't going to be there, but it's our job as project engineers and construction managers to ensure every single one of them is in place so the pour can be completed on the target date. If we miss any one of these things, if we forget to order the steel reinforcement, then suddenly if the pour is scheduled for the 1st of March, we might be waiting for the 14th of March for the reinforcement to come. And it's our job to take ownership of this. We want to be across every single thing that has to be in place to complete the task so we can get it ready on time. And unfortunately, the reality of getting these things ready is we can't just click our fingers and have them there. Getting these things ready takes time. Activity lead times is the time taken to get ready for an activity. So it's the time taken to organize every single one of these things. So we consider the materials we need for a concrete foundation. The steel reinforcement, there's a lead time for the fabrication. In a lot of circumstances, we'll actually need fabrication drawings. So we'll need to draft up a drawing that shows how we want the steel fabricated. We'll need to find someone to supply it. So if it's a big enough supply scope, we might even need to get a contract in place with them. And then we'll also need to go through a whole procurement process. So we'll need to get multiple quotes from different vendors so we can make sure we're getting the best value for money for the supply of the steel. All right, let's think about these timeframes and how they impact the date of the concrete pour. So say our drawings are ready for construction on the 7th of April. We then need to get quotes to supply and fabricate the steel. So we spend 4 weeks getting quotes, negotiating the pricing with vendors, getting internal approvals to sign off on the order. Because remember, if we're ordering steel for a major project, we could be ordering hundreds of thousands of dollars of materials. So we're going to need our management to sign off to say, yes, we've gone through the correct process. We've got 3 quotes. This supplier is okay to use. They've been vetted by our system. They comply with our quality standards. Only then can we then actually place the order. So then say that takes us 4 weeks forward. So we got the drawings on the 7th of April. It's now the 7th of May. This then takes us out to the 7th of June. So 4 weeks for design, 4 weeks for the quotes. On the 7th of June, we award the contract and place the order. So now we've got to wait 3 weeks for our actual steel to get fabricated. This means the steel is going to arrive on site on the 28th of June. And say it takes 1 day to install and do our pre-pour checks, which is probably completely unrealistic. Getting the drawings on the 7th of April is driving a construction pour date on the 28th of June. How crazy is that? What does this mean? This means for a concrete pour at the end of June, we need to be thinking about it in April. You want to think about why construction projects push out? It's not because people work slowly. It's because there's so many interfaces and things that have to be done in a set sequence, and that you can just see how these time frames completely blow out. Thinking about this in terms of activity lead times, you can see that it's potentially a 2-month process to order materials. These activities are captured in the master project schedule. It's your responsibility as a project engineer to be looking forward and thinking about tasks months in advance. When we talk about a 3-week look ahead and short range program, it's a great tool for scheduling and coordinating works on site. You can think about where the concreters are working in relation to the plumbers, or the fact that the electricians have to install utilities under a slab, but then the concreters want to go there next week to work. A 3-week look ahead is a great tool for thinking about that side stuff. But as a construction project engineer and manager, 2 weeks isn't enough. You have to be thinking months and months in advance to make sure things occur on time and aren't delayed. All right, so now we're going to look at how to develop a short-range program. This process is going to occur in 3 steps. First, we need to decompose the schedule. Take a time slice of the master project schedule and think about all the individual tasks that need to be done. So this is where we identify all the works that need to be done to facilitate this. Well, then we need to understand the lead times for each of these activities. So how long before the activity actually occurs do we have to be thinking about it? And that's what we use to create our simple structure of a 3-week look ahead. But then the next part of it is actually implementing the 3-week look ahead. So how do we implement a short range program? To implement a short range program, we need to methodically follow through everything that needs to be done to facilitate works and make sure it gets done. Now remember, as a project engineer, you're not physically doing the works. You're not going to be on site digging a hole. Well, you might be, but that's not typically what your job is. So it's your job to methodically follow through every single one of these tasks and make sure they get done. Sure, you'll be doing some of them yourself, like writing an inspection and test plan and getting it approved. But your principal job is to follow through every single item in this 3-week look ahead and make sure it gets done on time. So if you need to order materials, you got to go out and get quotes. You got to follow up the quotes. You got to make sure you then got to find the best vendor. You got to get the purchase order approved, and then you've got to place the order. If the supplier is taking time to fabricate it, you've got to hassle them every single day to make sure the materials are on time. And so effectively, your short range program becomes like a massive to-do list of showing everything that needs to be done to keep the works moving forward. We'll go back to the example of a concrete pour and we'll look at it rather than a 3-week look ahead. Think of it as a to-do list. So your pre-works, your excavation, you've got to make sure the subcontractor comes to site, or that you coordinate with your supervisors and foremen to make sure that excavations take place as planned. You'll need to call up the surveyor and organize for him to come to site to set it out. You'll need to look through the design drawings and work out all the materials you need. You need to place order for all the formwork and steel reinforcement. Then for the planned date, the concrete pour, you'll need to work out what labor is available, organize for them to be free to supervise the pour. If you have to book in a concrete pump, you have to call up a concrete pump supplier and organize them for a date to come to site. You need to prepare a safe work method statement, get it approved by the safety team, and then you'll need to prepare the quality documentation. So if you haven't done so already, you'll need to write an inspection and test plan, come up with a pre-pour checklist. And basically there's just all these things you're going to have to do to facilitate the works. And effectively, this is your primary job. And you can use the short range program as a tool for making sure that you're identifying all these tasks and you're systematically working through them and making sure that they're all done so the project can keep moving forward. So the short range program, to implement it, it becomes your to-do list. And it's your job to make sure everything gets done. You should never use as an excuse someone didn't do something. You should always take it on as your role to make sure that they're getting the task done. Just to quickly summarize what we covered. So we covered the key concepts of schedule implementation. We spoke about why scheduling implementation is such an important part of construction project scheduling, and it's often not even really considered a part of it. We spoke about short range programs, we spoke about how to develop them, and then we spoke about how to implement them. And remember, this is the primary tool as a project engineer you're going to be using to manage the construction works and make sure they're occurring on time. So it's a super important topic. And just to wrap things up, look, if you enjoyed this video, stay tuned because we're bringing out talks on every single topic that a construction project engineer and junior construction project manager needs to get a grasp on. So we're doing talks on scheduling, procurement and contracts, quality, design management, estimating, and construction cost control. And if you enjoyed the video and you think your career would benefit from learning how to master these fundamentals, then make sure you click on the link in the video description that will take you to our Learning Academy at Construct IQ.